Okay, good morning, GCSE folks. I will be with you very soon. I just realised I need to run and grab me a little map. Yeah, I need to go and do that. Okay, so I'll be back in un momentos. You've got something to think about here. Hi, Anne. Nice to have you here. So we've got a question here. If you want to start thinking about that, I would grab a pencil and try sketching it. Hi, Sheldon. Hi, Ruth. You're back, Sheldon. Yeah. Okay, I will be back in a second.
The graveyard.
Ah, you're here. Awesome. Who we got? Let's say some highs. Hello, Sonny. Oh, hi, Molly. Master. Okay, have a little think about this, guys. What does this house look like in 2D form if you were stood here and looking at it alongside that arrow? What would that look like? How would you draw that? Morning, Jacob. Hi, Drew. Okay, good morning, Maths. Some of you will have been with me for my all ages maths lesson. Some of you will just be joining for this, which is my GCSE/functional skills maths lesson for those people who are looking for exams. So we're going to focus on the understanding during this. And then when it comes to exams, unfortunately, you do need to do the practice bit, because it's essential you can actually like write things down in the way they want to see it in the exam situation in order to get the qualifications. So this is a bit more of a, yes, this is exactly what you have to do. Hopefully we can get the deep understanding during this bit. Today we are looking at scales, plans, elevations, and maps. They all link together really nicely. So I asked you to look at the picture of this house and say, what would it look like from the viewpoint of if you were stood at the arrow? So I'm going to show you that picture again, but this time I'm going to give you three options. I'm going to give you A, B, or C. Okay, they're rough shapes rather than an actual scale drawing. Oh, we've got, so I like this. Yeah. Molly, that's a really good way to describe it. Yeah, using shapes. That's essentially what I did here, is I used shapes to combine them together to make the shape that you would think you would see. Okay, so if you're looking from this direction here, do you think you would see A, B, or C? Which one would it look like? A, B, or C? We're not in agreement here, are we? We're not in agreement. Feels like this sort of question should be so straightforward. And it blooming isn't! It's so frustrating. This is something called plans and elevations, and they actually assess this on GCSE and functional skills too, I believe. But it's useful to know. It's useful to know. What do different objects look like from different directions? So the front view, well, what are plans and elevations? What are they called? So first of all, let's just start off with some technical language, okay, because you need to know this in an assessment. It's also useful if you want to do anything to do with like architecture, anything like that. So the front view is if you're looking at something front on. So the front of the house here is literally looking at the front. The plan view is if you were looking from the top. So if you're in like a helicopter hovering above this, what would it look like from the top? And then the side view is what we were talking about. This one or this way. Okay, and I'm going to come back. I am going to answer this question, but I'm going to come back to it after doing this activity. Okay, so I asked you, if possible, to bring a hardback book with you. Hardback book. And what we're going to do is we're going to open up the book like this to start with. Can you see? Like, open it up like this and stand it on a surface. Okay, so I'll do that, and then I'll show you what mine looks like. Doesn't matter what size your hardback book is. It doesn't matter what size it is at all. Okay. So can you see this here? Can you see that? I've got that open on my surface like this. Okay. So you can see from the side, it's almost like a triangle shape that is created with like a little flat bit where the spine of the book is. Yeah. So my front view would be this. It's actually a trapezium, this is called. So it's just been cut up. It's a trapezium. Now, I am going to show you what mine looks like. But before I do, you do this. Get yourself directly above it. So get your face directly above it and look down on your book. If you're slightly higher up, it can help. And without try to get rid of what you're expecting to see and see what shape you actually see when you're looking directly down on your book. What do you see when you're looking down on it? Oh, no problem. It's okay if you're late. No problem being a bird. What are you seeing when you look down on it? Do you want to have a look at mine? Should we have a little look? I'm going to just move this so that I can flip it down. Okay. Okay, so hopefully this will work. Ah! No, it didn't. I'm going to just have to hold it above. Right. Can you see? How am I angling this? Maybe I'll do it from this. Here we go. Do it from this angle here. Okay. So we're looking directly down on it. And lots of people expect to see some sort of triangular shape. But actually, if we get directly above it, what you see, I don't think I'm showing it at the right angle here. Okay. What we actually have is a rectangle shape. What we're actually seeing, we can tell because of depth perception that this bit is higher. But what we can actually see is the base of the book, which is creating a rectangle shape. It's not creating a triangle at all. What we can actually see is a rectangle shape. It's the widest bit, which is the base sticking out. So this base bit here, where the four corners are touching, are creating a rectangle. And that is the overall shape we can see. We can see more detail to it than that, and because of our depth perception, we can tell some of it is higher and some of it is further away. But what we're actually seeing is a rectangle, not a triangle at all, which I think is really, really hard to get your head around. Yeah, some of you are seeing that. So using that, if we actually have a look at our house, if I go back to our house, I've got it here. I've confused myself. What have I done? Ah, here we go. What have I done? I'm confusing myself. Okay. Right, so, okay, let's try this again. So, if we look at our house here, and I've tried to do this using the colour of the house. This house, despite this being, the roof is at an angle. It's got made this sort of almost triangular shape. It's not joined up. But if we were looking from up here, what we would see is actually a rectangle. We would see a rectangle. It would have a line down the middle, and we would know using our depth perception that this bit is closer to us than the outer edges. But essentially, the overall shape we would see is a rectangle. We might even see the chimney, a bit of a different colour here, but it wouldn't be going outside of this rectangle. It would be contained within it. The front view is relatively obvious. We've got like a box, so we've got a rectangle with a triangle on top of it. So it's actually a pentagon, it's a 5-sided shape, but we would see exactly that. When we look from the side, what are we seeing? So you can try this with your book as well. You can try this with your book. Standing it on its side and then looking from the side, what are you seeing? It's not quite exactly a house shape, but you get the roof bit. You do get the roof bit. So if you go back to your book now, and I've turned mine around so we can see this. If we take this as the side view of the roof of the house, you might notice that I don't see a triangle. Even though, if I turn it around, we can see, look, it's like the roof of the house. We've almost got that triangular shape. But I'm not seeing that from this side view. When I'm looking from the side, I just see a rectangle because I'm not taking into account which bit is closer and which bit is further away. And that is the same with the house that we've got here. We're not going to be able to tell that which bits of the roof are closer and which bits are further away. So if the roof is a rectangle and the main bit of the house is a rectangle, then altogether we are actually just going to get a rectangle. So I've tried to do it with the different colours there to show this bit of the house is a rectangle and the roof is also a rectangle. So actually it does end up being C. It ends up being C, and I think that's really, sorry, B, not C. I think this is so counterintuitive because we expect, because of what we know about the shape of the roof, for it to be A or C, but actually it is B. We just end up with another rectangle, and that in itself, yeah, I think the only thing you can do is practice looking at objects and picturing them in 2-dimension. It was really baffling for me once to just like get my head around that when, I don't know if you've ever done this, when you're drawing something, if you've ever done an art class, drawing the sky is a really good example, and drawing clouds, and automatically you'll grab a white pencil to draw clouds. But an art teacher once told me, no, actually look at the colour of it. Stop seeing a cloud. Stop actually seeing a cloud because you're tainting it with your brain and what you're expecting to see, and actually look at the colour. And it was very rare I actually needed to pick up that white pencil. And it's the same with this. It's look at the actual picture and try and get rid of your preconceptions. Okay, next challenge is to do something. I've said bring a piece of paper and a pencil, or at least I hope I did. Something to draw with and something to draw on. You can do it on paper, you can do it on a whiteboard, you can do it anywhere. What I'm going to do is I'm going to ask you to do a very rough plan of your home. Okay, a very rough plan of your home where you live. But I'm only going to give you 30 seconds to do it. Okay, so grab a piece of paper, grab a pencil, or whatever you're drawing with, whatever you're drawing on. And I'm going to time 30 seconds for you now. And I'm going to join in. I'm going to do the same thing. Let me just get my timer sorted. Oh, it's on minutes, not seconds. That's not helpful. Are you ready? I'm just going to give you 30 seconds. Are you steady? Go. Go. Can you see the 30-second timer? Ah! Ah! That didn't feel very long at all. That didn't feel very long at all. Okay, I'm going to stop that there. Okay, right, looking at the picture. Looking at your picture now. Is it the same size as your house? Is it exactly the same size as your house? Did you grab out a piece of paper that was equal in size to your house in order to do that? Or did you, like me, grab a piece of paper, and I started off just doing, this was just a bit of the downstairs of my house. I put some stairs in, a couple of rooms in. I didn't get very far, but I did it small. I did it quite small. I was thinking like on Rightmove, like the layout of a house so that you get an idea of what the size of each room is and things like that. That's what I was thinking. That's what I was thinking. And of course it would be ludicrous to think that every time we draw a picture or we do something like that, or we're planning something out, that we would do it exactly the size of the actual object. We can't carry these around with us. So we have to scale it down to actually fit on a piece of paper. And this is called a scale model. So I've got one here. I've got a picture of one actually. So we've got a little scale model here that an architect has created, or it might be a landscape actually, because they're talking about the garden here, and this is like little bits of inside of the house as well. Okay, so this is a scale model. But this is only going to work, if we do something. And that is that we have to decide on a particular number that we are going to divide all of the actual measurements by. So you can see this is a toy house. This is a toy house here. Let's pretend it's a real house. And the height of this house is 4 meters. The width is 5 meters. And the depth of this house, or the length of this house, is 3 meters. What we need to do is decide on something called the scale factor in order to create an actual scale drawing of this, where we can reliably use it for measurements and to plan things out. So we tend to do this by using something called a ratio, or we write the scale as a ratio. So here I'm going to use the ratio, or the scale, 1 to 25. That means for every one of something I draw on the picture, I know that in real life it's going to be 25 times bigger. So if this is my real life version, where it's 4 meters, 5 meters, 3 meters, I'm going to have to divide all of those measurements by 25 in order to get my scale version. Now, I know what you're thinking. Well, I might actually, no, I don't know what you're thinking. But maybe you're thinking, well, these numbers aren't going to divide by 25 very well. And you are quite right, they're not. Often when we look at scales like this, and we're looking on a larger scale, we use different units. And we're going to talk about this in terms of maps, actually. Those different units can cause problems. So what we need to do is find a unit that's going to work on both the scale drawing and in the real life issue here, in the real life object. That's the word I'm looking for, object here. Okay, so for these ones, because they're all in meters, these don't naturally divide by 25 very well. So the first thing I would do is convert these into centimeters. So I know 100, there's 100 centimeters in a meter, so 400 centimeters, 4 meters becomes 400 centimeters, 5 meters becomes 500 centimeters, and 3 meters becomes 300 centimeters. Now I can divide all of these by the same number, and that's key. If I don't divide everything by the same number, it's not to scale. So I have to make sure every single measurement is divided by the same thing. Divide them all by 25, and I can get how I would draw this to scale. And this should fit on your piece of paper. You should be able to measure out 16 centimeters. We should be able to measure out 20 centimeters, and we should be able to measure out 12 centimeters. And now this will fit on a piece of paper by using that scale. Okay, so one for you to have a little go at here. Here is a car. I looked up the measurements of this car. They were a little bit awkward, so I adapted them slightly. But the width of the car is, we'll say, is 180 centimetres. The length of the car, 420 centimetres, and the height of the car, 130 centimetres. I would like to do a scale drawing of this using the scale 1 to 15. So if you can work out, yeah, absolutely, Ruth, turn it into centimetres. That's a good idea. I did that bit for you for this one. What would be the measurements of this car for the scale drawing? What would be the measurements for this car for a scale drawing? I thought I didn't actually say bring a calculator to this, and I should have done. I should have actually said that. So absolutely use a calculator for this as well. You can possibly hear me in the background dropping everything everywhere. Okay, 5 more seconds and I'm going to go through these. Don't worry if you've not done all of them. It's not about speed. It is all about understanding. You can do practice later on, absolutely. Okay, so the scale here was 1 to 15. So that was the scale we were given. The smaller number is going to be the scale. So that's going to be the drawing. The 15 is real life. So the bigger number is real life. So that's saying in real life we're going to get 15 of this measurement for every one of the measurement you're getting on the picture. So if I want to go from the real life measurements to scale measurements, I need to make them 15 times smaller or divide by 15. So I wanted to divide each of these numbers by 15. You may have done these on a calculator and spotted something here. If we do 18 divided by 15, 180 divided by 15, and I've forgotten what it is now, we get 12. So that one would be 12 centimetres. It's staying in the same units. I'm not converting the units here. They're remaining the same. I can draw 12 centimetres on a piece of paper. Then I'll do 420 divided by 15. That gives me 28. So that one would be 28 centimetres. Now you might have noticed with the last one, it doesn't give you a whole number. That is absolutely fine. We just deal with that by writing it as a decimal or a fraction. So you might have got 26 over 3, which we can write as a fraction as 8 2/3. So we would write 8 2/3 centimetres. Or we can write that as a decimal. It will be 8 and it's 666 recurring. It goes on forever. If we were to round that to 1 decimal place, and I believe, have I done a lesson on, I think I've done a lesson on rounding, so you can go back and have a look at that. If I was to round that to 1 decimal place, it will be 8.7 centimetres, because it's beyond the halfway point between 8.6 and 8.7. So we would round that probably to 1 decimal place, would be quite sensible there. Okay, on maps. Did anyone manage to bring an OS map? Have you seen one of these before? I just ran and grabbed one of my husband's. It's a well-used one because we live quite close to this. This is an OS map. This is used for walking. So if you do any outdoor walking, always a good idea to take one of these with you. Oh gosh, give me 1 sec. My laptop's decided to run out of battery. Don't want that to happen because you'll all disappear. How exciting. These sort of maps tend to come with a standard scale, either 1 to 25,000 or 1 to 50,000. Now this one's a bit tatty, but I can show you here if I zoom in. You can see the scale. Can you see it? I'm getting a bit of glare here. It says 1 to 25,000, just in the corner there. I'll try and make it so it's out of the light a bit so you can see that. Can you see it? It's really, really small there. 1 to 25,000 is the scale. But it also gives you some other information. 4 centimetres is 1 kilometre, 2.5 inches is 1 mile. So they're different. Can you see that, or is that zooming in? I don't know if it's it doesn't know what to focus on, my camera. I think it's designed to focus on people rather than objects. There we go. So it's given you some different scales that we can use there. I'm going to talk about this one here, this 1 to 25,000. The other one you often can get on an actual OS map is 1 to 50,000. So what that means is that because this is covering such a huge area, such a massive space, so you can see that's covering like lakes and mountains and things like that, we have to use a really big scale because 1 centimetre in real life is not very far to walk, but it's quite a big amount to fit on a map. And that's why it's such a massive scale, so it can cover such a massive area. So we're going to look at using those scales now. I'm going to give you this one here. So using this massive scale, we're going to use oh, 2-minute silence at 11. I did forget about that. Thanks for the reminder. So scale 1 to 25,000. The distance between the two pins, so these two pins here, on this map is 5 centimetres. Using this scale, what would be the distance in real life? What would be the distance in real life? I'm going to give you a little second to think about it before I go through it, because I think, well, no, I know for sure, actually, that when you think about something before being told the answer, it actually creates more connections in your brain and makes it more likely that you are able to retain the information and use it. Let me just angle my camera a little bit better there. What is the distance in real life between these two pins that are 5 centimetres apart on this map? And the map is to a scale of 1 to 25,000. Okay, I'm going to give you another 30 seconds to think about it, and then we'll have a look at this together. Okay, that wasn't 30 seconds, I don't think, but it'll do. Okay, oh, I forgot that I did this. I was supposed to show you those 3 options. I had 3 options. I had 125,000 centimetres, I had 1,250 metres, and I had 1.25 kilometres. I had different options that I'd intended to show you there, but I feel like I've given quite a lot of silence there already. So let's have a little look at this. Let's have a little look at this using my little whiteboard over here. Okay, so we know, what do we know? That's what we want to start with. What do we know? So we know what the scale is. We know it's 1 to 25,000. This is going to be the real life. This is going to be the scale drawing. The scale drawing is the smaller bit. We know that on the scale drawing it is 5 centimetres. We want to know what the real life bit is. So here we have, to get from 1 to 5, we're multiplying by 5. So we're going to want to do the same this side. We're going to take that 25,000, we're going to want to multiply that 5 by 5 straight away. So I would just pop that straight into my calculator. I would just do 5 times 25,000. In fact, I've got that on the screen there. And it gives you 125,000. 125,000. Now the key here is, what units is that? What does that number mean? What does that 125,000 actually mean in units? Let's have a look at my 3 options again. So I gave you 3 options here. What does it mean? 125,000 centimetres, 1,250 metres, 1.25 kilometres. So it means, in this case, it means the 125,000 centimetres because I was working in centimetres. So I can't just change the units here. They've got to stay the same. If this one's centimetres, this one's got to be centimetres too. However, some of you have spotted that this can actually be the kilometres as well, because there is 100 centimetres in a metre. So if I divide this by 100, I am going to get this same distance but in metres. So dividing this by 100 gives me 1,250 metres. Now if I want to go from metres to kilometres, I know there's 1,000 metres in a kilometre. So I'm going to divide by 1,000. And that gives me 1.25 kilometres. So technically, all three of those are absolutely spot on. 125,000 centimetres, 1,250 metres, 1.25 kilometres. All three are the correct answer. This one is probably the one we would say state because it's the most straightforward. But if you're thinking in real life, if you're actually walking the distance, it's much more common that we would talk about walking a particular distance in kilometres. So that's why the conversion bit is important too. Okay, so what have I done here? Ah, yes, okay. Wow, okay, we've done that one quite quickly. I thought I had done more than that. I have done, we're straight on to, excitingly, a quiz. We are on a quiz already. Let me just see how many questions I've got for the quiz. 1, 2, 3. Yeah, right. So it's 3 questions on the quiz, but you're going to have to do some calculations for 2 of them. Or 1 of them. We're going to have to do some calculations. So be prepared that one of them requires some calculations. You're going to pick 3 letters and you're going to be able to rearrange those letters when you get them into a word at the end, okay? So you're going to rearrange them into a word. We'll start off with this one. So the arrow is pointing at, is it the plan view, the front view, or the window view? If you think it's the plan view, you'd write an A. If you think it's the front view, you'd write a B. And if you think it's the window view, you would write a C. Question number 2. If I want to find the real life size of this car, so this car, the model of this car is 5.5 centimetres, the scale is 1 to 75. If I want to find the size of the real life car, will I multiply by 75? If you think that, you put P. Will I divide by 75? If you think that, you put Q. Will I add 75? If you think that, you put U. Yeah, Sally, the window view would be the oh, good question. I was being a bit silly with the window view. I was being a bit silly. But yeah, in this case, I think it could be the side view. Okay. Question 3. The real distance between these 2 pinpoints is 2 kilometres. What is the distance on the map? The real distance between these 2 pinpoints in real life is 2 kilometres. What is the distance on the map? The scale is 1 to 50,000 and your options are 4 centimetres, 40 centimetres or 400 centimetres. I'm going to give you a little bit of time on that one because this one takes a little bit more working. Okay. People thinking, having a little guess on that one. Yeah, that one's more challenging, isn't it? That one is more challenging. I told one of them would require some calculations. Let's have a look at the other two. And then I'll properly go through that last one, actually. I'll properly go through that last one because it's really, really common exam style question. Okay, so the first one. The arrow is, I was being a bit silly with the window view here. The window view isn't an official, like, mathematical language. You've got the front view, looking at the front, you can have side view, and the plan view is the one looking at the top. So it was the plan view for this one. I want to find the real life size. This is the scale of the car. We want to get bigger. So we're going to multiply by 75 in this case. So it's P. If we add 75, it doesn't keep all the dimensions to the right scale. Multiplying and dividing are what keep things in proportion to each other. The last one here, I'm going to go through in a little bit more detail. I'm going to talk about what we know and what we need to work out. Okay, so we know that the scale is 1 to 50,000. We know that the real life distance is 2 kilometres, so I'm putting that on the same side as the 50,000 because that is the real life measurement. We're trying to find out what the map measurement is. Now it's quite hard to compare 2 and 50,000. We've been talking about dividing by a particular amount, multiplying and dividing by a particular amount, but that one looks like it's not going to work. There is a way to make that work, and I'll talk about that in a second. But what can be helpful here is to convert it into different units. So we could say 2 kilometres is the same as 2,000 metres. Still, 50,000 is smaller than that, so it's not going to go into 2,000 metres. So again, we can convert it again. And we can say, right, well, how many centimetres is that? There's 100 centimetres in a metre, so I would multiply that by 100. So that means 2 more zeros, essentially, which is 200,000 centimetres. Now I've got a number that 50,000 fits into exactly. To get from 50,000 to 200,000, I am multiplying by 4. So therefore, I'm going to do the same on this side. I wouldn't do it this quickly. I would be using a calculator as well. I would multiply by 4 to get 4 centimetres. We can, however, use the kilometres too. We can use kilometres. We can say that actually it doesn't matter because this isn't using units. The 1 and the 50,000 don't have units. We're deciding on the units here. So we could say, oh wait, well actually, to get from 50,000 to 2, I divide by 25,000. So I do 1 divided by 25,000 as well. As long as I'm doing the same on both sides, that is fine. And I get then 0.00004 as my answer. And that makes sense because it's in kilometres. So that is right. That is the correct answer. It's just that we don't tend to talk about 0.00004 kilometres. We tend to talk about centimetres in this case. So then I would want to convert that back into centimetres. So if I want to go, I would do this in 2 stages. I would go to metres first of all. I know there's 1,000 metres in a kilometre, so I'd times that by 1,000, and that's going to give me 0.04 metres. And then to go from metres to centimetres, there's 100 centimetres in a metre. So to go to centimetres, I'd multiply by 100, and I get 4 centimetres when I multiply this by 100. So either of those works absolutely fine. And if you're not asked for particular units, it doesn't matter which answer you give. It's only if you're asked for putting it in particular units like centimetres. And exams do tend to do that sort of thing because they're looking to assess, they're looking to tick some boxes basically, and they're saying, right, we want to assess this skill in this question here. It does end up right, map! Yeah, I missed that bit. Yeah, you end up with an M, an A and a P. It does absolutely end up spelling map. Well done, guys. Okay, this is good news. We're going to finish by 11 so that I don't have to try and be silent and time myself for 2 minutes live on screen. So this is great. We can do our silence privately, which I quite like. I quite like doing a private reflection on my own. Thank you so much for joining me. I love live. It's got like a special sort of energy that you don't get any other way. So I really value your time here live. Thank you. These lessons are absolutely free and you can grab the workbooks. I've put all the links to videos where you can review all of this and specific exam questions and practice all on the workbook, which you can download off my website whenever you like. And all of that is there, but I put quite a lot of time into producing that and creating these lessons and delivering the lessons. So people choose to pay £5 or £6 a month to fund them. And I say a thank you to those people by sending out an activity pack. So the activity pack, I've got a brand new one, but I didn't click the blooming thing to approve the printing last week. So it's been delivered today and I'm so excited. Right, but if you're already a member, you've got this one. You've got the fractals one, explaining fractals in hands-on ways, through quizzes, through different activities in there. Really cool area of math. I've got a weather one coming, and if you sign up this week or next week, you're going to get the fractivities and the weathertivities all together with the freebies as well. So this comes with some really cool origami paper and some stickers. The weather one comes with a straw to do a chaos activity, and it comes with a piece of paper to do a sun activity as well. I'll show you all that properly next week. But if you want to become a member of the Maths Mob, you can do that from the link at the top of my page. Thank you for joining me. 2 minute silence at 11. Thank you for the reminder on that. So appreciate that. And I will see you either on Friday on YouTube, where I'm going to repeat this lesson and my all ages lesson, or I'll see you back here this time next week for more. Bye for now, guys.